Okay.
You can always drop me the file if you're busy.
So it should be recording right now. Yeah, it is. Hello, everyone. This is a secure software composition analysis features overview. So the plan is to go through all the group features that you can see on the product page for our group, which are dependency scanning, container scanning, license management, or maybe soon license compliance, and vulnerability database. And we also have some other functionality. First one is security report, but we also might have the dependency list coming soon. So starting with dependency scanning, here's the documentation for it, explaining how to set it up, what are the supported language and package managers, because when you talk about dependency for a given language, we can have several package managers. For example, for JavaScript, we have npm and yarn, both relying on the same type of packages. Anyway, you have a different way to configure it. Note that the currently supported way is to use the inclusion of our vendor template, so that you can always have a version of the job that is compatible with your version of GitLab, because it ships in every release of GitLab. We also have some ways to customize it by overriding some of the variables at the global level or just for the job itself, like here. I've skipped the older definition. You get the output, the JSON format of the report that is generated there, and some explanations. The fact that it is displayed on the security dashboard, way to interact with the vulnerabilities like dismissing, opening an issue, and for yarn vulnerability, opening a merge request if there is a patch available.
So if I configure this, it runs during verify against an MR, or can it run against something that isn't an MR?
It's part of the pipeline. So any pipeline you run can run those tools. So if you are opening an MR, it's actually showing the pipeline of the branch you're trying to merge. And you have also, some documentation about the dependency list and how to contribute to the vulnerability database. We'll go back to those items later. So talking about dependency scanning, the project is here. So dependency scanning is one of our features relying on a specific architecture, which involves an orchestration layer. So the dependency and scanning job itself is an orchestrator that will look at your project, and based on some rules, we try to detect which packages and package manager your project is using. And based on this, it will spin new Docker containers with the dedicated analyzers. So we also have a bunch of analyzers which are shared. You can find here an analyzer for SAST, but also for dependency scanning. So for example, we have retired.js for dependency scanning and Gymnasium. So dependency scanning job itself don't do much. It detects the technology and spin up some new containers with the analyzers per each technology. You have some way to configure it, obviously. And there is one specific thing about dependency scanning is in case you want to disable the remote checks. This is for the usage of Gymnasium, because Gymnasium is a client-server application and it scans the dependencies on your project, but the vulnerability is remote. The vulnerability database is remote. So it will extract the list of packages, not the exact version, but the list of packages name that you are using, and ask the Gymnasium server database, do we have some advisories for those packages? And then it will compare, it will get back the advisories and compare if one of the version of this packages you're using are impacted by the advisories or not. If you don't want this to happen, you can disable it. So talking about dependency scanning analyzers, we have 3 of them today. First one is Gymnasium, which cover all the package manager that we have today. And we have Retired.js specifically for the npm packages, and we have Bundler Audit for the Ruby gems. Any question about this?
That Bundler Audit, is that our own tool or is that an open source tool?
No, Retired.js and Bundler Audit are open source tools. We are only using only open source tools except for Gymnasium. Gymnasium is the only in-house tool for all the security features. So here's the source of Ruby Bundler Audit. Okay, any question about dependency scanning? For example, here's a template, the vendor template I was mentioning above, that this is a job definition that will be included in your pipeline. So there are a lot of funny things there, but the most important thing is that we are generating a dependency scanning reports. This is what will be pushed to the Rails backend at the end of the pipeline. All right. Moving to container scanning now. So container scanning is a different setup, a different architecture. We don't have an orchestrator here. We are relying on one unique tool, which is the Claire scanner, which is an open source tool that embed a daily updated database of Claire, so that you don't have to spin up a Claire database and update it every time you are executing the container scanning job.
So it's always checking that live?
Yeah, the job itself, if you look at it, there is no wrapper project today for container scanning. So the job itself is just calling directly the Docker images from Claire local scan and Claire scanner. So it's loading. Oh, sorry, ClareDB. So it's spinning up the ClareDB, the Claire local scan, downloading the Claire scanner executable, and running it in the same job. So this might change in the future, but currently we only have this tool, so we don't have the need for the orchestration layer.
Okay, and when you say that it's checking containers,
it's not checking containers, it's checking images. It's a bit weird naming, actually, but what the input of this tool is the image that you are building and that will run in the container when you deploy it.
So it's kind of like, this is what I will be spinning up. Check it to see if there's any known failures. And is this just for Docker, or is it Docker and Kubernetes? Like, what kind of container images do we handle?
I think that officially Claire support Docker images, and another one, IPPC, yeah. This is another spec for images.
Okay, so that's the 2 type of images that if you have them as part of your CD process, we have access to the images and this scans those.
Yeah, the usual workflow is that in the previous steps of the pipeline, you'll be building your application and generating a Docker image. And this is what will be passed as input to this scanner. So here you can see that we are passing CI application repository, CI application tag, which are the default, which are filled by the default values from the Auto DevOps pipeline, or if you use the basic definition we provide for building your application, this is what will be built by each time you have a pipeline running on your application. So you are building the Docker image, pushing in the local on the Docker registry of your project, and then this job spin up in a later stage will Docker pull this image at some point. Docker pull here, yeah, and then scan it. So container scanning is based, Clear Scanner is based on a CVE database. That's why it keeps being updated. What else do we have about container scanning? Nothing much. You still have the same common features, which is uploading them to the Rails backend and getting them in the security dashboard and being able to interact with those vulnerabilities. Any question about container scanning? Oh, it's a bit of debate. Oh yeah, sorry, no, it's not in use yet. We are planning to have a wrapper tool, a wrapper project around container scanning. So this is not ready yet. Sorry for showing that. Yeah, you had a question?
So this is, so you're making it a little more proactive in terms of understanding what's going to be in the container before it's actually spun up, is that?
Yeah, actually a container is a container is spinning up a specific Docker image. You can eventually do things in that container after, but we can't know what will be done in advance. What we can know is what has been packed into this image. And this is what is being done.
If you think of it for future, like if there's a particular image that IT were giving everybody's laptop, we would be checking that before they installed it on their laptop, and then the defend team would be looking for changes to that. So we're kind of, before you go and place this as your production thing, are there CVEs that we know about now?
Perfect.
And then if you change configuration, defend will have to look.
That's great.
I'm sorry, Cynthia, I don't hear you.
I know I have my PC's having issues. Sorry, but.
By saying that, it's worked perfectly. Okay.
And the
didn't get it, sorry. Okay, let's move on then. Next one is license management, going to be renamed in license compliance. So this feature is also based on one unique tool, which is License Finder, and it has some pretty wide support. We have one wrapper project around license management that we are maintaining, which is a.
Could you explain to me what a wrapper project means? Because I'm not exactly sure.
Okay, so as we are relying on external tools, sometimes one unique tool and sometimes several tools, we have the need to wrap them instead of using them directly, because we want to do some things before and after the tool itself executes. For example, we want to do some preliminary setup before running the tool to adapt to the project. And we want to manipulate the output reports to adapt it to our common reports, because we want to have a common report structure for every type of analysis that we are doing. So what we want is that the output of the job itself is directly a common report, a compatible common report. So that's why we are wrapping this into separate projects. This is not the case, as I said before, this is not the case yet for container scanning. So this is why all the logic is into the script job. This is a bit complicated to debug and to work with. Whereas having a dedicated project, we have way more flexibility and easier maintenance. And we can have a dedicated release cycle and etc. etc. So a lot of benefits of doing this. So for license management, we do have, so it's basically a shell script that will do a lot of different things and finally execute the license finder application on it. So license management is not producing a vulnerability report, a security report like the other security scanning feature. It's a bit different. And it has a bit different workflow within the RAISE application, because it's not about providing security vulnerabilities, but license information. You also can configure it in different various ways. And there are some definition about the way to define policies at the project level for your licenses. So you can whitelist or blacklist some well-known licenses. And based on this, in the merge request, when you are introducing new dependencies and we've scanned the licenses, you will be flagged if those are compatible with your policies or not.
Now, the license finder open source tool is reliant on the developers doing proper files, right? Stating their dependencies.
I don't have a lot of knowledge about the underlying tool, to be honest, so I won't be able to provide you an accurate answer. My guess is that they either have to look at the dependency repository itself, if it's vendored, or look at the remote code, or eventually or possibly they can also look in the package registry, because sometimes this metadata is available there. So there are a lot of different ways to achieve this. And I'm pretty sure it can also depend of what technology is being scanned. Okay. This is an example of the report for the pipeline view. So as I said before, the job is running for each report, each pipeline, sorry. So you get a report on the pipeline view itself. But if your pipeline is attached to a branch that you're going to merge and there is an open merge request, the report will also show up in the merge request. And if you're running that on your default branch, it will also show up in the project dashboard and the group dashboard. Okay. No more question about license management?
It shows up on the group dashboard. Is that technically true? Or is that something new that's been added? Because I don't remember seeing that.
Oh yeah, no, sorry, you're right. Sorry, I just mixed the things. This is not a security report, so it won't show up in the security dashboard. Thank you, Sam, for picking this up. Yeah, totally right. This is not a security, so it doesn't provide vulnerability, so it won't show up in the group dashboard and the project dashboard. Sorry about that. One last thing that I wanted to precise here is that this job doesn't require Docker in Docker. We are not spinning a specific Docker container here. Instead, we are leveraging the image property of the job to directly provide the license management Docker image. So what happened here is that the job itself will spin a container of that image. So the script will execute within the context of the image, instead of having a script that will just run a Docker run command to execute a new container on the image itself. So it makes it easier to set up for some customer that don't want to set up a Docker in Docker infrastructure. Or actually, to set up a privileged runner that will allow to use Docker in Docker.
And I just pulled up the license finder README, and it says it specifically uses the package manager in order to find dependencies.
Okay. So it probably fetches the metadata on the package registry. Because I might be wrong. It's been a long time, but I'm not sure every package manager provide a command to get the license from the package. But this might be an issue actually, because this means it relies on the metadata of the library to be accurate. Because if you have a license.md file in the repository, I think it will take precedence over what metadata you're putting in the package.json file, for example. So this might be something we might have to work on. Okay, next one is the vulnerability database. So we recently done some work on this. There's just a small section here in the dependency scanning documentation about it. So this is about the in-house gymnasium scanner that is relying on an internal vulnerability database, like I was explaining before. So what this database was previously private. What we've done is to open it into a.o. So I have a public access to the database. There is a particular specific licensing. So there is a terms file that explain what you can and what you cannot do with this data. But at least the goal that we wanted to achieve by opening this database is to allow our customers, our users, to check the database if it was containing known CVEs that they were particularly aware of, and they really wanted to have their applications checked against them, so they can do it. This is not the real database used by the tool. We are maintaining this repository, the single source of truth. So the process is we are checking external sources, adding advisories to this repository, and once it gets merged into master, it gets published on the Gymnasium PostgreSQL database. And this is PostgreSQL database that is being queried by the Gymnasium client in the Gymnasium analyzers in the dependency scanning job. Make sense? You may ask why.
Explain that, so we put everything in and people can see the list before we put it in, but they can't see the database. Is that what that essentially was?
Yeah, the reason why we've done that is all the architecture of Gymnasium and the database are always being made private and private source. So it was easier to just open the database itself before we make sure we want to open the tool code itself. So another approach would have been to provide a new endpoint in the API to just provide search feature and things like that. But we also wanted to allow people to contribute to the database. So it would have required more work if we wanted to do that directly with the online application, the infrastructure that we have in place with Gymnasium. Whereas if we're leveraging a repository, we already have all the contribution feature made by GitLab product itself. It's very straightforward because it's just a matter of looking at, I just take an NPM example.
So starting in 12.0, if I go in here and I look for a CVE that I'm interested in and I can't find it, I can follow directions, I'm assuming either in the docs or in the README, to add that.
Yeah. That's the second goal that we wanted to achieve here. Allow people to contribute to it. So we now have a basic workflow that allow people from other teams of GitLab to eventually help us to keep the database up to date, or anyone from the wider community to contribute.
So I should probably make sure I include this in the 12.0 release post.
Yep. what else can we say about the vulnerability database? Yeah, there are currently discussion. There's a plan to make this vulnerability database out of our own responsibility, but instead we will hand this over to a security research team from the security department that will be responsible for maintaining this database up to date, but also contribute to other scanners, other open source tools to improve the capabilities of all those tools that we are providing, so that our own security team can leverage those tools. And then I had two Misc analyzer, but I actually already talked about the analyzer when talking about the orchestration layer of dependency scanning. One important point, it's a bit more technical, but it also helps to understand a bit how things are going with our different features, is we have two different kind of data sources. So this another diagram that I made when implementing the first feature, leveraging the database. Depending on what part of the UI you are viewing, the data might come from different sources. So if you're looking at the group dashboard, the data will come from the database, and it will show you the current state of your application, which is the vulnerability that we have found on your at the default branch on your projects. With 12.0, we are switching the project dashboard to the same source of data. But currently, before 12.0, the project dashboard was relying on the artifacts, like the merge request widget and the pipeline view, which is the UI is fetching the raw reports produced by the job in the pipeline. So the job is writing the report into an artifact, make it available for being queried. And this is created by the front end and displayed directly from there. The main difference is what goes into the database is only for the default branch, whereas the artifacts are available for all branches. The goal here is to make all the source of data going through different processes so that at the end, it gets out with clean APIs with the same JSON formatting. So whatever the place you're looking at, you will have the same structure of data. I should have the API also here because we now have an API, public API to download the vulnerability the vulnerabilities from your project.
So once we get everything using the database as its reference,
we can't.
Are we gonna, no?
No, we can't leverage the database for every vulnerabilities for every branches. It's a too high volume of data, and it actually doesn't make sense.
Mm-hmm.
The reason is what we want to have in the data is to make some deeper filtering analysis. This will be leveraged by the dashboard and things like that. But you are not interested or as much interested in doing such things with the data coming from a branch that is not yet merged in your application. What you can see in a branch, so in a merge request, is what will eventually be added to your project, to your live application. But until you click on the merge button, it's not a real threat. It's not a real vulnerability. So there is no point in adding this data to the database and showing it in the group dashboard. I mean, we could still add it to the database, it's a more technical matter, but there's no point in showing it in the group dashboard. So what we have today is, until it gets merged, this is something just potential. So you can still deal, the set of feature we have today can still rely purely on the artifacts, and that's fine from a performance point of view. But if you want to achieve more high-level features, aggregate the data, do some statistics, we need to leverage the database, and that's why we are doing this for everything happening on the default branch. Right?
Okay, because yeah, I'm sort of thinking eventually people might wonder how many for example, vulnerabilities were prevented by people seeing stuff. And so I'm thinking eventually they might want to be able to query that. So even if we're not sending maybe full information, we may want to think about that in the future.
Yeah, but those are more about statistics.
Yeah.
This might be achieved in a different way. Because
to have like some kind of stats database where we send
Yeah.
summary counts or something. Yeah.
Yeah. And if you think about it, we already have something related in feedback, because on the merge request, people can dismiss a false positive vulnerability or create an issue from there or merge request if this is a true positive. So we have small feedback there. We don't have the raw statistics, but we already have some feedback. All right. Anything else we can say about this? Just we'll have another look, but I think we covered everything. Yeah. Security reports. So this is what we're talking about, the merge request and pipeline views.
So all the reports right now, they get generated only when the pipeline runs. And so in theory, if I wanted a daily report, I would have to schedule an automatic daily pipeline run.
Yeah.
Okay.
And this is actually one of the issue with the group dashboard today, because this is the way we are counting things. So if you don't have a pipeline running for a given day, you don't have data. So it's a bit hard in the display right now.
All right, cool. Thank you.